Hello, welcome to the third day of this chapter on right triangles. Today we're going to investigate a little bit more about Pythagorean's theorem. We want to know what the relationship with Pythagorean's theorem is with non-right triangles. Well, look at this obtuse triangle over here. The biggest side is 12, so we'll use that as C. And the two smallest sides I'll have 6 squared plus 7 squared. And I want to know how that relates with 12 squared. That's 42 plus 49. And this is 144. This is going to be 91. How does 91 relate to 144? Hopefully you're saying it's less than. So in this case, those are all less than. In this other case, we have 6 squared plus 7 squared is, we don't know how it relates to 8 squared. 6 squared plus 7 squared, we found out on the previous problem, is 91. And here, we know 8 squared is 64. Now this is the opposite. This is greater than. Now when c squared is bigger than a squared plus b squared, like this case, it makes a really wide angle, making this obtuse. When c squared is less than a squared plus b squared, this angle is smallest, or the smaller than 90 degrees anyway, so that makes it an acute triangle. So our notes that we take on this, if a squared plus b squared is greater than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then we know the triangle is obtuse. If a squared plus b squared is equal to c squared, then we know that that triangle has to be right. Now, let's classify these following triangles as right, acute, or obtuse. Now, if I have these three sides, you take the two smallest ones, 3 squared plus 4 squared, and you put 6 squared on the other side. Now, this is going to be 9 plus 16 is equal to 36, which is 25. Since 25 is less than 36, that c squared is too big, and that makes it obtuse. Now let's try this one. We have 7 squared plus 40 squared. See how that relates to 41 squared. So we know 7 squared is 49. 40 squared is 1,600. 41 squared is 1681. Well, this is 1649, which is going to be less than 1681. Again, c squared's too big, so that makes it obtuse. Let's try another. 12, 10, and 14. So we take the two smallest sides, see how they compare to the biggest side. Well, this is 100 plus 144, which is 244. 196 is 14 squared. Now that c squared is too small, making that angle acute. All right. Now we have another objective in today's lesson, and that's to find the longest diagonal in a rectangular prism. So what's the longest pole you can fit in a box, for instance? I think about this problem a lot when I'm trying to buy some boards at Menards or Home Depot, and I want to figure out how to fit it in my car. Now, if we have these sides, we want to find this distance, which isn't actually a right triangle yet. Now, if I draw this diagonal right here, then if I just look at the bottom of my rectangular prism, hopefully you know the bottom of a rectangular prism is a rectangle, and I just drew this line across the bottom, which would be a right angle. And I know this side is 9 and 2, so I could find my hypotenuse, which is that dotted line, by saying 9 squared plus 2 squared is equal to c squared, or 81 plus 4 is 85. So the square root of 85 is this distance. Now that creates another right triangle through the middle of our box that I shaded in blue here, where we have a right triangle where the yellow dotted line on the bottom, that distance is the square root of 85. It's 4 high. Now to find my hypotenuse, I'm going to take root 85 squared plus 4 squared and equal that to c squared, which is 85 plus 16, which is, I think that's 101. Now I take the square root of 101, which we can't simplify, and that's going to be my distance from A to B. Square root of 101 centimeters. So square root of 100 is 10, so just a hair above 10 will be the distance from A to B. Now there is a simpler way, but it's an extension of the Pythagorean theorem. I call it Pythagorean, I forget, I didn't spell Pythagorean correctly. Let's try it again. Pythagorean theorem for 3 dimensions. So that's a squared plus b squared plus c squared is equal to d squared. Now if I take 9 squared plus 2 squared plus 4 squared and set that equal to d squared, that's 81 plus 4 plus 16 is equal to my distance squared. And that's going to be 85 plus 16, which is 101. Now I square root 101 and I find that distance. So we could use this new formula, this Pythagorean's theorem for 3 dimensions, or we can do it using 2 dimensions, but then you have to use Pythagorean's theorem twice. Whatever way makes more sense to you, go right ahead and use that. Now that's the end of today's lesson, so rate yourself on a scale of 1 to 10, and hopefully you can start the homework.